How's it going, everyone? It's Ken Q here, and today, we're going to start, we're going to embark, we're going to begin a new project. I'm really excited for this because it's something I've wanted to do for a long time, like a project on this kind of scale. But, in your everyday life, hobbies are kind of hard to stay motivated for. But when you're doing it to, hang out with other people and chat and chill and maybe inspire people to do these things themselves, then it's a lot easier to do, really, to get motivated. So that's the plan, and I want to tell you a little bit about what I want to do first, and then we'll get right into it. So I'm gonna maybe put on some background music here. Turn that down just a touch. All right, so the idea is that I want to create kind of a wireless environmental sensor. So I'm hoping the basics will be temperature, humidity, and pressure. But I'd like to set some stretch goals to see if we can do like maybe carbon monoxide and smoke as part of that too. But that might be like smoke might be a real stretch. Carbon monoxide maybe not so much, but we'll see. I'll see what kind of sensors exist as we go through the design, and we'll decide as we go what happens. But the idea being that we want this device to be kind of wireless, battery powered, so that you can put it in any room or even every room, and have it monitor over time the environment in that room. And I know people are thinking there's plenty of products like that out on the market. And that's true, but a lot of them have proprietary interfaces and you can't actually get to the base data very easily. And so rather than trying to figure out how to do that, I thought it'd be more fun to just try to create one of these devices from scratch. So that's the plan. And kind of some of the goals along the way are to make it a little bit like a modular architecture so that we can swap out bits and pieces for other bits and pieces down the road. So for instance, it's an environment sensor for now, but maybe we want to swap out the sensor head and put on a different sensor head to make it a different type of sensor. Still wireless, still the same base architecture, but different sensing and processing capabilities. Now, I want this thing to be wireless and all of its information to be transferred to a server that I have. And really, it could be anything on a network because the idea is to use a network interface and you just code in the address that it has to go to and just let it go. So this combines a lot of different technologies, some of which I'm familiar with, some of which I'm not familiar with. And so it's going to be both a learning experience, but also kind of a demonstration, I guess. But I think overall it's going to be, a bit of a rocky road as we go. But we'll learn a lot. We'll make some mistakes. Maybe we'll blow up some electronics. Who knows? And at the end of the day, I want to get the circuit board manufactured, get a case for it, housing, and just have this completed almost product at the end of the day. So this is going to happen in a few different phases, and I don't know how long each phase is going to be because there's a lot of things I don't know yet. The first phase is obviously going to be kind of a high level definition and design of what this thing needs to be, what it needs to do, how it's going to look, what the architecture's like, the interfaces and things like that. And then the second phase is going to be kind of a more or less a product survey, i.e. go through and look at different sensors, how they interface with things, answer some of those questions and start doing the electrical circuit design. And you'll see once I start doing the high level design, I kind of have a plan to break this down into manageable chunks that can hopefully be accomplished in discrete parts so that we can kind of go start to finish on something, some part of something in each stream. So it's not going to be like, yeah, we'll do the whole design of the whole thing in one stream. No, it's going to be a high level design for the whole thing, and then there's going to be different boards that we need to design, and so we'll pick parts for a board, we'll order them, we'll pick parts for another board, we'll order them, and then we'll start doing prototyping based on what comes in and what's delayed and all that. And then once we've prototyped and made sure that things work, then we can go ahead and figure out the PCB layouts. And then from there, it'll be, you know, make a PCB layout, make two PCB layouts, whatever, however many PCBs there will be, get those ordered, and then do a case design, figure out how to get that ordered, and then it'll just be a matter of testing after that. So obviously there's a lot that needs to happen. And yeah, hopefully it doesn't take too long, but I do foresee it taking a significant amount of time, especially because of component shortages in the world today. That might delay things. So if, for instance, we do the high level design and then we pick parts and start doing the electrical design, I'm not, very experienced with electronics. I'm, moderately experienced with electronics. So it is likely that I'll just say, okay, here's a bunch of stuff that I think will look like the electrical circuit. Let's just order all the parts, test it, and tweak the electrical circuit by prototyping it, which I think is pretty common. So I don't feel too bad about doing it that way. But the problem is we might get to a point pretty early on where we have a significant delay because of components, which is fine. We'll just pause while we wait for components to come in, and I'll keep people updated on the status of that. And we'll do other things in the meantime, and then we'll come back, and as components come in and we can start prototyping different pieces of it, we'll do that. So today is going to be all about the high level definition and the high level design of this thing. So I'm going to go ahead and open some software, and then we'll transition over to a different display once that is opened. Here we go. Here we go. Yeah, let's do it. So those of you who have been on my channel before will recognize this program. I've used it a few times, most notably in the gravity simulation. Just going to take a sip of brandy. This is Enterprise Architect. It's a pretty handy tool for doing software design, but also for kind of a system design. It allows you to talk about, high-level components, how they're going to interact, all of that good stuff, using UML or SysML. And I like this one because it's got a lot of capability built in. It's pretty easy to use. It looks nice. It's in continuous development. You always get upgrades for as long as your license is active. And it's pretty darn cheap. Hey, Gil, how's it going? Can I shorten your name to Gil? Is that legit? I hope that's legit. Tell me if it's not legit. So yeah, this is Enterprise Architect, and we'll go ahead and get started with some design. So to begin, I'm going to create a view. What kind of icon do I want for this view? This is just going to be a simple view, and this is just going to be where I'm going to store some requirements. And so the requirements are going to be, if you're familiar with any sort of systems or software design. Yeah, legit. Hope you're having a wonderful day, Gil. And I hope it's stopped raining where you are. Requirements essentially define what this thing is going to do. So I'm just going to add a diagram to make things easy. Let's see, do I have systems? SysML? Do I not have a SysML plugin? No, I guess I gotta use UML. That's fine. I'm just gonna use a class diagram here, because it doesn't matter what the diagram is. Ah, still raining, eh? My rain has turned to snow, so that might tell you a little bit about where I am. Change perspective, requirements. Here we go. I am just going to write some simple requirements. So first, now there's a tool. I'm going to find it. I don't remember where it is, but I'm going to find it. Options, properties, no. Configure. Auto names encounters. Okay, type. Requirement. EQ. And 0, 1. Apply on creation. Close. Delete. Yes. Bam. And so we can define what we require of this product. So first and foremost, I'm going to acronym the wireless environment sensor to be WES. That's right. It's going to be WES, my homie WES. The WES shall measure ambient temperature. How often do we want it? Once every 5 minutes to a precision of 0.1 degrees Celsius. Ba-ba. Let me show notes. Number 2. Shall measure relative humidity. Same interval. And the precision doesn't matter because it's just a percentage. Ba-ba-ba. Whoops, that's changing the name. What am I doing? Clearly I need another sip of brandy. 1 second. How precise should atmospheric pressure be? I'm just going to Google what kind of values of atmospheric pressure are typical. Sea level 101.325 kilopascals. .1. Ba-da-ba-da. Ba-da-ba-da-ba-ba-ba-da-ba-da. Okay. Now, in typical requirement fashion, you use shall for things that are mandatory and should for things that are kind of goals or stretch desires. Now, most companies will take everything that's a goal or a stretch goal or a desire or something like that and just throw it out because it's a waste of money. So if a customer ever comes in and says, well, we'd like it to do this, that means it's not going to happen. But if it's, if it says shall, then it's mandatory and they have to do it. But because I'm not a faceless corporation, I'm just me, I'm going to use should, and I'm going to try to achieve the shoulds if possible. So just because I want to see if there's a sensor out there that can, in a small form factor, measure carbon monoxide and include that in there. Just so that this device can be a little bit versatile. Like, it's easy to see that you'd want to measure temperature, humidity, etc. in like bedrooms, living rooms, etc. But it'd be nice to be able to stick this into, for instance, the mechanical room of a house where you've got furnaces and things running, burning gas, and have it let you know if there's a problem and carbon monoxide starts to build up. But I don't know if those sensors are, very, very like custom, or if you could just buy like a carbon monoxide sensor and integrate it into a circuit. So we'll see. It'll be a goal, but it won't be mandatory. The other thing is, so those are kind of the data we want. And then I want it to transfer all measurements to an external server. And then the other big one is I want this thing to be battery powered. I want it to last 6 months. Ideally, if I can get more than 6 months of battery life out of it, that would be great. But I think the minimum is going to be 6 months. So that's going to come down to a lot of like management of the processing and when things are on and doing things. I'm just writing words, Gil. I'm not even doing any programming yet. It's just words. None of this means anything. It's fine. But I think this overall project is going to be, it's going to be a learning experience, that's for sure. There's a lot of things like the circuit design. I haven't done like PCB layout or anything like that ever in my life. So it's going to be a learning experience. And I think the entertainment will come when I start, burning out electronics and releasing the smoke out of electronics. But for now, it's just kind of high-level conceptual design. It's just words. It's words on paper for now. Okay, battery powered. What else is important about this? Yes, modular architecture. Do. So I want to be able to pull off the sensor board and swap it with a different sensor board, and then obviously reload the code with new code to control that sensor board and go from there. I don't want to have to redesign, the wireless interface board and all of that from scratch if I want to just swap out sensors. Okay, and then last but not least, it was just in my head, but I forgot it. Oh, yes. How do I write this? I want to be able to use the same design and the same software and have like 10 of these little sensors everywhere. So the code that is loaded on the microcontrollers will have to all be the same, but there will need to be some sort of jumper system on the boards to set the identity of each sensor so that you can load the same software on all of them, and then you just flip the jumpers to create an identity for that one, and then close the box, put it in a room, and then you can identify based on that identity that it's the data from whichever room you put that box in. So I don't even know how to write that into words without writing a paragraph. Is that how you write uniquely? Probably. Ba-ba-ba-bam. All right. I think that's it. That's all I need. Some people like to have thousands of requirements. I am not some people. There is, glossary. Edit. Wes. Hey. I love this software. I don't think I can say enough how much I love this software. So I've defined the glossary item, Wes. So now anytime there's a description where Wes is mentioned, you can see the acronym and see that it says wireless environment sensor. It's a beautiful thing. Such a beautiful thing. Okay, let's add a new view. This is going to be the component view. Structural design. And add a diagram. We will use the structural UML, and we'll use a component diagram. All right. Boop. So this will be the Wes logging software. Let's add another component actually, network server. Just to be descriptive. So on a server somewhere, we're going to have logging software. And then we're going to have Wesley Snipes. No, I'm kidding. Wes, and Wes will have a network controller. Boop. A sensor head. Boop. And a what do I want to call it? Primary controller. Just call it the MCU. There we go. And now we can do things like add a port here, add a port here, and associate these ports. This connection will be, actually I'll do it differently, but let me hide labels. Just going to organize things because this is going to get a bit weird. A bit weird quickly. Not that it isn't already weird. Let's see. I'll just do all the connections first. Hide label. Things are moving on me. Here we go. Associate. And oops. Associate. Ba-bam. Awesome. So I'm going to do it as a class, to be honest. Nice. I love the spam. Class. And it's going to be sensor network interface. Stereotype. It's going to be a specification. An interface specification. I'm not going to put any information in there yet. Because I don't really know what it's going to be. Can I do this? Yeah. Okay. And then let's see. Network controller, microcontroller, sensor head. Okay. Power interface. What else? network data interface. And the last one will be sensor data interface. Okay, now we could do this. No, not that. This one. Can I lock you? Thank you. Are you not locked? There's a way to make it not selectable. There we go. Yeah. So both of these are going to have a power interface. This one is going to have a sensor data interface, and this one's going to have a network data interface. And for the network data interface, this is going to be SPI. I know that. Properties. Notes. Fine, let's put it here. I want the sensor data interface to be I2C or I squared C. And then for the power interface, there's going to be probably 3 volts, maybe 5 volts, depending on what the needs are. I want a reset control, and I want I think that's it. So the reset control will essentially be able to shut down the boards when they're not needed to save battery. So since we'll be running every 5 minutes reading the sensors and sending off the data, then I don't want to have to have all of those electronics powered up all the time. It'll just be the primary microcontroller that's powered up most of the time. And it will essentially shut down all the other boards until it's ready to do a measurement. It'll start them up, give them, a couple microseconds or milliseconds of warm-up time, take a reading, transmit a reading, shut everything down, start a timer again. Network interface, UDP, board. I want the board identifier on there, so that's the jumpers that we'll set. I want. What do I want? We're not going to do timestamp, because then that would mean I would have to keep track of time, and I don't want to do that. The logging software will timestamp the data on receipt. UDP, board identifier, no timestamp, and then sensor data, obviously. Wow, that's ugly. Not too bad so far, eh? All right, let's drill down into a... Right. Because it's not selectable. That's because it's locked. Add composite structure. Bam. So we'll just drop this link. 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 There we go. Too much going on. Okay. So now I'm going to drill just a small level deeper into the design to kind of make sense of some of it. And it's not going to be the level of electrical design, but it's going to be kind of one level away from that. And I'm just going to go components, because if I start talking about classes, people might think it's software. So we have the wireless front end. Boop. That's the actual RF portion, amplifiers, etc. We have the Wi-Fi controller. Boop. And then we will have a interfacing MCU. And the identity information. Yeah. In this main MCU, we have obviously MCU. It's really an microcontroller board, but and we have power supply. What else are we going to have? Those are the main things for that one. It's the brain. I'll just rename that to MCU board. Okay. We will put in here a sensor MCU. And these microcontrollers, like the sensor microcontroller, is going to be very simple. I suspect the interfacing microcontroller is going to be a very simple device, but the one on the main board is going to have a lot of capability, I think, or a lot more capability. We are going to have temperature sensor. We are going to have a humidity sensor. Pressure sensor. And hopefully a CO sensor. Wow, that's great spelling. Great. I'm going to need to make this guy bigger. Going to need to make this guy bigger. I have to make everything bigger, but to begin with. Port. 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 I know, like, what is he doing? It's just adding ports to everything. Like a lunatic. And how does he know how many to add? Well, he has no clue. He has a reasonable guess, but really he has no clue. I wish I could just press a button to hide all labels. There's got to be a way. Oh, I missed a port. I could go for some port right now. That would be delicious. Bam, bam. Wow. Okay. What kind of lunacy have I got myself into? All right, so simple enough. We have this association. That's power to the main microcontroller. Oh, processing. I can delete some of these. What? There we go. So, because I kind of know the design that I want, it's pretty easy for me to write these out. And because it's not my first rodeo with microcontrollers, I also have an idea of what is possible. But if at this stage you don't know what interfaces and things you want, the best bet is to just go down to the next level and start figuring out what kind of hardware you're going to need. And that will start to dictate your interfaces. Like, you know, I've said on the previous one that I want SPI and I2C because I know those interfaces typically exist for these types of things. And because I've actually found a microcontroller, not a microcontroller, a Wi-Fi controller that I want to use for this project, because most Wi-Fi controllers are really, really like loaded up with functionality, and as a result, they take a lot of work to get up and running. And I don't want all that overhead for like a simple project like this. But I found one that has a really, really straightforward and simple way to use it, which is nice and compatible with just using a microcontroller. So I know what interface that chip has, and so that's the one that I've specified. But in terms of like these sensors, I don't actually know what interface they're going to have. I suspect some of them will be analog interfaces. So I'm just going to mark them down as analog for now. And once we start picking hardware, we can just refine all of this information. My picture's got to look pretty. I need straight lines. Oh, that's not pretty. There we go. That's pretty. So, Hey, later, Gail. Have a good one. I look forward to seeing your stream tomorrow. Interface. The reset interface. Uno. Dos. Okay. Power. We'll just assume it's 3-volt power. Oops. That one. Nope. Behavior, not selectable. Behavior, not selectable. Behavior, not selectable. Okay. Sensor I2C. Gosh, how has it already been an hour? SPI. There. Parallel digital. So essentially it'll be a set of jumpers that when set a certain way will read into the microcontroller as zeros and ones, and based on that we can have some sort of identity information. Oops. So the data that the wireless controller needs is slightly different than what the interfacing microcontroller is going to need, but they're both going to be SPI. I don't know if that's going to be a problem, if I'm going to have to find a microcontroller that can support 2 SPI, or if I could use like a chip select type of functionality, but we shall see. And then from the Wi-Fi controller to the wireless front end is some sort of baseband RF, which I believe is built into the chip, the Wi-Fi chip. Like the Wi-Fi chip that I want to use has the Wi-Fi controller and the wireless front end both built in. And then I think all of the sensors are actually going to be analog interfaces. I'm going to mark it just as one and just link it to all of them. But there's going to be subtle nuance to each one depending on the selected sensor. Whoops. So, yeah. Boop. 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 There we go. So you can already kind of plan out what you need for this. Like between these two boards, I need a reset pin, I need however many pins for SPI, and I need the power supply pin and ground pin. On this side, you know, likewise, I need reset, I2C, supply and ground. So yeah, that's nice structural design. And the beautiful thing is we could start at this like top level and then break down into this level. So if you want to just look at it here, you can see, okay, this is what's needed. This is what the design is, but if you want more detail, you can then drill down into what's in here. It's a wonderful thing. So what's next? What's next? Next, we'll just do the behavioral design. And this is going to be pretty, I don't know, mundane. Sometimes you have a lot of different behaviors because you have a lot of different components doing different things. But in this case, it's kind of a sequential flow. There'll be a timer every 5 minutes. That timer will, expire. It will wake up the boards, etc., etc., etc. Like there's a defined flow to it. So we are going to add a sequence diagram. And we are going to add in everything. It really depends what level we want to talk at. But what I will do is I will take the logging software. I will take this MCU. Power supply doesn't matter, so I'm not going to bring it on because it doesn't communicate anything. It just simply is there and is providing power. Let's put this all the way on the end. This MCU is the meat and potatoes. We are going to take the sensor head. We're going to take the sensor MCU. We are going to take temperature sensor, pressure sensor, humidity sensor, and the CO sensor. Okay. And then we'll take the interfacing MCU, the Wi-Fi controller, the identity information, and then the wireless front end. Now, obviously, the wireless front end doesn't talk to the logging software directly, but we'll show it talking directly just for the sake of simplicity. So we'll have a fragment here. 5-minute timer. It's not an alt. You know what? The starting condition for this is that 5 minutes has elapsed. Wow. Okay, so wake sensor MCU. This might be asynchronous. Let me think about this. How's the microcontroller going to handle this? It's going to change the pin to wake it up. then it's going to wait. So this is async. And then wait. There's going to be some sort of timeout to wait for it to wake up. Then the sensor MCU is going to sample temperature. Just make these asynchronous. For the sake of simplicity, sample pressure, sample humidity, sample CO, and actually, it's not going to do this once. It's going to essentially loop doing this once per second. Once per second. So once it's started up, it'll begin basically its sampling process, and it'll store it into a register that is accessible over an I2C interface. Then it'll read sensor data. And the thing will provide sensor data. Oof. Shocking, I know. Activation, extend source activation. Oop. This guy's always on. And this one, activation, extend source activation up. Activation. There. So the sensor MCU is on. It returns data from the call, and then we will asynchronously shut it off. So I just want to add a note here. Timeout time is TBD. Likely wait 10 seconds. Just so that I can get a few samples before writing it out. But we can figure out what works. We don't want to stay on too long because we don't want to burn power for no good reason, but we do want the sensor reading to be stable. interfacing MCU. Asynchronous. Then we're going to wait. Wait for a particular time. While we are waiting, it's going to get ident info. Connect to wireless network. Wireless connection active. And what? You know what? We're not going to wait on this one. We'll do an async and then we'll interrupt. Connection ready. That's a return. Extend source activation down. Send data. Sensor data. Send data. Sensor data. Ident. Transmit RF. And since we're using UDP, it's all async from there. Data. Data sent. And we will just extend source activation down. And we will power down the MCU. Interfacing MCU. That's also async. Activations. And then start clock. 5 minutes. And okay, so here, yeah, so this stays on the whole time. Send data, blah, blah, blah. And then we get to the bottom here. Apply timestamp. And write to file, write to log. Ident, sensor data, ident, timestamp, sensor data. Get timestamp. And I'm doing this because it's easier. Like it would be nice to timestamp at the source where you get the data. However, I don't want to have like an absolute clock. I mean, I could probably get one over the wireless network. But if I'm just getting a clock over the wireless network from the server, then the difference in time doesn't make a huge difference. Like it'll be like some fraction of a second off in timestamp. Like we'll get it at one point, but write it at another point. And so it doesn't really make that big of a difference. But in terms of complexity of the hardware and the programming, it adds a lot to try to do that all. Just going to organize things just a touch here. Compactify. Ba-da-ba. Ba-da. How close together can I space things before it gets out of hand? Go, zoom out one step, and I think we can get it all on one screen. Great. Properties, diagram, set as default. Bam. So that is the high level design of what we want to do. So we have, the requirements, and I think we satisfy them all. These will come down to what sensors we use. We have the 5 minutes baked into our design. We have these 4 sensors baked into our design. We have this interface baked into the design. This will come down to, you know, one, we've made design decisions to power things down and keep their runtime to a minimum. But also it'll come down to selecting components and battery sizes and all of that good stuff. We've got the modular architecture. So here, network controller, microcontroller board, and sensor head, those can be swapped out. So if instead of a network controller, we want to do like a Zigbee or some other wireless, we can swap that out as long as it uses an SPI interface. There isn't going to be a ton of changes here, hardware-wise, just this board, obviously. But it'll just be a software change to communicate with that. We can change out the sensor head as long as we maintain this interface. There's no hardware change to the MCU board. Good. Modular, yeah, that's the modular architecture. And then design for use of multiple of these in one setting. So this identity setting should accomplish that for us. And that's about it. And then we went through, quickly laid out what the behavior of this thing's going to be. And that's it. We're good to go. So next time, what we'll do is we'll get started on probably the sensor board, to be honest. And we will, in real time, go on some of the electrical component websites and pick the sensors, pick microcontrollers, and see if we can get a preliminary design together at the electrical level. And then after that, we'll do the wireless board. And then based on those two, we can pick the microcontroller in the middle and figure out the power for that, etc., etc. And so, yeah, that's basically it. I guess I'm having a lot of fun with this design already. I hope those of you watching and those of you who will watch the VOD will also enjoy this. If you like this kind of design content, please let me know. Maybe hit subscribe, hit like, etc., etc. I really enjoy this kind of stuff, and I kind of want to grow a community that also enjoys this kind of stuff. And so, yeah, just let me know if you like it. And if you're just here for more of the gaming stuff, then that's fine too. I got no beef with that. But yeah, so I hope you enjoyed, and I hope you look forward to the next phase. I think the next part's going to be really fun. I mean, for me, it's really fun. It's going to be looking at a lot of data sheets, figuring out how things work, and selecting bits and pieces. But until then, I guess have fun, enjoy, and just keep being yourselves. Thank you. Bye.